In this video, we'll talk about what is a quadratic equation. Then we'll look at example of quadratic equations. Some of these exams are a bit tricky. They look like quadratic, but they are not quadratic. And then we'll discuss the meaning of solving a quadratic equation. Let's start first by defining what's a quadratic equation. So a quadratic equation is an equation of the following form: ax squared plus bx plus c, where a, b, and c are real numbers, and a should not be 0. In other words, you are looking for an equation with the highest exponent of x equal to 2. It should not exceed 2, and it should exist to consider as a quadratic. And this form that we see here is known as the standard form for the quadratic equation. Now, quadratic equation does not have to be in the standard form. So let's look at some example to understand better what's a quadratic equation. Let's look first at this example: x squared plus 5x plus 3 equal to 0. Now, this is directly on the standard form. So a in this case is 1 and b is 5 and c is equal to 3. Let's look at another one. Now I could have a 3 plus 7x plus 2x squared equals to 0. If we look at this equation here, we can see also the largest exponent for x is 2. And there is no other term that have a larger exponent than x, so that's important. And also we can see that we have the x term and the constant. If we look at this form here, we can see that it's not actually in the standard form, but still, this is considered as a quadratic equation, since we have this term x to the power 2. We can, of course, rearrange this one to make it in the standard form. So we can write it as 2x squared plus 7x plus 3 equal to 0. So the order of the term is not important. As long as you have the x squared term somewhere, it's a quadratic equation. And this x is representing a number, so we know that when you are adding numbers, it doesn't matter which order you add them up, the result will be the same. If we look at also a third example, we can have something like this is also a quadratic equation. We have the x squared term. This is the key term that you are looking for. And in this case, we don't have the x term, but still, that doesn't matter. As long as you have the x squared term, this is a quadratic equation. Similarly, you can have something like x squared plus 4x equal to 0. And this is also a quadratic equation. The constant is not there, but the x squared is there. So we can see, the order is not important of this term as long as you have x squared. Similarly, you don't need to have the x term or the constant. In fact, even if you have something like this, like x squared, it's a quadratic equation. Now let's look at also other examples. An example like this: 4x squared plus 3x equal to x squared. Now in this case, you can see I have actually two terms that are x squared. So is this quadratic? Yes, this is still quadratic. What we can do, we can put it on the standard form by subtracting x squared from both sides. So if you do that, what you will get is 4x squared minus x squared plus 3x equal to 0. So when you subtract, you will get 3x squared plus 3x equal to 0. This is again a quadratic equation. Also, it does not have constant. Look also at another example here: x squared plus 3x plus 1 equal to x cubed. Now, when you look at this side here looks similar to the standard form. However, if you notice, we said that the largest exponent that you should have for x is 2. But here we can see that we have 3. So this is a cubic term. So this is actually a cubic equation, not a quadratic. So this is not a quadratic equation. Okay, let's look at also at another equation. So here we have x. If you look quickly at this equation, you may assume that this is quadratic because we have seen other examples where you have different term at different side, but after we arrange them, we can have x squared plus something x plus constant. And here we can see that we don't have any cube, so you may be thinking that this is a quadratic equation. However, if we expand the other side, so x times 2x, that give you 2x squared, and then x times 1, that give me x. If I want now to move all of this to one side, so I can subtract this from both sides. And then what you will get is 2x squared plus 5x plus 1 minus 2x squared minus x. And when you subtract this, you will get 0. So this will cancel out. And then 5x minus x. So this gives you 4x plus 1. So this one is actually not a quadratic equation. This is a linear equation. We don't see here the square term. The square term is missing. So this is not a quadratic equation. So these examples show you what quadratic equation. Now also let me explain to you what's the meaning of the roots of quadratic equation or the solution for quadratic equation. Let's write a quadratic equation and use it to explain the meaning of solving quadratic equation. So let's take this quadratic equation, x squared 5x plus 6 equal to 0. Solving quadratic equation means trying to find the value for x that satisfies this equation. So what value of x? If I substitute it here, I will get 0. Okay, so this equation, we call this is the left hand side, and this is the right hand side of the equation. Now, of course, the right hand side is 0. In the left hand side, we want to find value for x that will make it equal to the right hand side or 0. There are different ways to solve this one, but we are not going to go into this method in this video. I'm trying here to explain the meaning of solving quadratic equation. There will be other videos that explain the process of finding the solution. Let's do a trial and error. So if x is 1, let's try x equal to 1. What we will do is to substitute the value of 1 instead of x in this equation. So the left-hand side will be, if we substitute 1, we'll get 1 squared minus 5 times 1 plus 6. You can see this one is actually equal to 2. So this means that this one is actually not a solution for the quadratic equation. So let's try x equal to 2. Now the left-hand side of the equation, again, we're going to substitute x with substitute 2 for x. So we'll get 2 squared minus 5 times 2 plus 6. So this is 2 squared, 4. And if I add it to 6, I get 10. Now the negative term, the only negative term is this one, 5 times 2, which is also 10. So you'll have 10 minus 10, that gives you 0, which is the right-hand side. So this is actually a solution. Okay, let's try another one. If x is equal to 3, the left-hand side, again, we substitute 3. So get 3 squared 5 times 3 plus 6. Let's add the positive terms. 3 squared is 9 plus 6 give you 15. And the only negative term is this one. So 5 times 3 is 15 also. So 15 minus 15 is equal to 0, which is also equal to the right hand side. So this is also another solution. So this is the meaning of a solution for the quadratic equation, trying to find what is the value of x that will make the left-hand side equal to the right-hand side. In this case, we find 2, which is 2 and 3. Now, in general, for the quadratic equation, it can have two solutions, or one, or in some cases, there is no solution at all. Again, there will be other video that explain how you can get these numbers. Here, we just did a trial and error to find. Finally, if you find this video useful, please give it a like and don't forget to subscribe to the channel and turn notification on so that you get notified about new content. Thank you for watching.